What's up? This is Dr. Taylor Crick, host of the AutoImmune Doc podcast, and this is my literature review YouTube channel. So I review studies that are relevant to things that I talk about on my podcast, on the AutoImmune Doc podcast, but also things that are just relevant that I think are important that people know. With things that people are commonly suffering from, in kind of a functional medicine setting, or even for practitioners who are, addressing these situations clinically. So this one's from Frontiers in Cellular Neuroscience, and it's about mast cells. And mast cells are one of my favorite topics. We have a podcast about them. It's episode number 23, 24, I want to say. And yeah, mast cells are absolutely fascinating. So mast cells in stress, pain, blood-brain barrier, neuroinflammation, and Alzheimer's disease. So mast cells are these cells that are what's called sentinel cells of the immune system. So they line tissues that interface with the outside world, like the skin, the sinuses, the lungs, the gut, but also in the brain, also the joints and connective tissues. They're more highly expressed in rheumatoid arthritis and the synovial tissue, and in the uterus and in endometriosis, and they're just heavily implicated in inflammation. And they're like the landmines. And it's like, okay, if there's an inflammatory fire and you look for what set that off, well, then you look to the hand grenade that set that off. And then you might look to, like, well, who's the person or who's the trigger that pulled that pin out? And a lot of things trigger mast cells, like stress, but also toxins like mold, allergens, certainly, LPS, etc. Stress, I think I already mentioned that. So anyway, let's look at this. So mast cell activation plays an important role in stress-mediated disease pathogenesis. Chronic stress causes or exacerbates aging and age-dependent neurodegenerative diseases. The severity of inflammatory diseases is worsened by stress. So there's definitely a connection between stress and diseases of inflammation, which is most chronic diseases today. Mast cell activation dependent inflammatory mediators augment stress-associated pain and neuroinflammation. Stress is the second most common trigger of a headache due to mast cell activation. Alzheimer's disease is this, that, and the other, and stress is associated with an increased level of neurotoxic beta amyloid peptide. Stress increases cognitive dysfunction, generates amyloid precursor, hyperphosphorylated tau, neurofibrillary tangles, and amyloid plaques in the brain. So basically, stress is associated with all these bad things. Stress is associated with headache, stress is associated with mast cell activation, stress is associated with the severity of inflammatory diseases, and stress is associated with the aggregation of all this crap in the brain that's associated with dementia and cognitive decline and Alzheimer's disease. Stress-induced amyloid beta persists for years, even after the stress exposure. Stress activates the HPA axis, which increases the formation of amyloid beta and disrupts the blood-brain barrier. Mast cells are implicated in nociception, which is pain perception, and pain. Mast cells are the source and the target of corticotropin-releasing hormone. That's the HPA axis that modulates stress, or that responds to stress. Mast cells are the source and the target of that mediates neuroinflammation. So it's saying that in stress and neuroinflammation, mast cells are the mediator that respond to that. So already, this is a lot of stuff, but it's saying that mast cells, which can be triggered by multiple environmental things, including stress, lead to pain perception and different problems in the brain, including cognitive decline. So, stress, blood-brain barrier disruption. A lot of this paper is about blood-brain barrier disruption. Mast cells are implicated in neuroprotection, pain, neuroinflammation, neurodegenerative diseases. They release preformed mediators as well as newly synthesized mediators. And there's a lot of literature behind this. And I have other papers on this channel, even talking about different things with mast cells, certainly. Mast cells act upon nociceptive neurons or through glial cells. And I want to go to some of these pictures as well. So here's some of the bidirectional interactions of mast cells and nociceptor neurons, so neurons that detect pain. So mast cells, which this is a pretty, elementary picture of it, but they have these preformed granules in them, like TNF alpha, which is highly inflammatory, and histamine, and biogenic amines like serotonin, dopamine, histamine, prostaglandins, leukotrienes, cytokines. All of these things can be disrupted. So mast cells get activated, and they can release things with or without degranulation. So they release these cytokines and chemokines that basically trigger these pain receptors and increase the perception of pain in pain-related syndromes, like fibromyalgia, but also in things like headache. Mast cells are pretty stinking cool. Stress, pain, again, it talks about a lot of things in here, and I'm not going to go through all of it because I like to keep these videos short. But this talks about stress, pain, and neuroinflammation. Interestingly, this paper is from 2019, and a lot of the mechanisms discussed in this paper are similar mechanisms to what happens in long COVID. There's mast cell mediated release of different neuropeptides and things that trigger neuroinflammation. Mast cells can turn on microglial cells, trigger neuroinflammation. And there's also this blood-brain barrier disruption and microvascular damage leading to this myriad of symptoms of fatigue, anxiety, brain fog, vertigo, things like that. So let's go to there's another picture here that's good. So what this is saying is that chronic stress, okay, so chronic stress, war, chronic diseases, dementia, noise, isolation, unstable job, spouse. I say, job, life, bills, relationships, we all know what that is. Acute stress, same things a lot of times. An injury, it could be loss of a loved one. It can also be things like this, like temperature swings, pressure changes, environmental stressors. So you walk into a moldy room, or somebody's exposed to a toxic chemical or pesticide, high competitions, presentations at work, intermittent fasting. Exercise is a stressor, but it's a good stressor, but it triggers a stress response still. And what this is talking about is prolonged stress. And it triggers these reactions. So these hormonal reactions, hypothalamus reactions, but then also, amyloid precursor, amyloid beta, neurofibrillary tangles, phosphorylated tau, like we already talked about, decreased volume of brain regions, decreased growth factors, BDNF, increased oxidative stress, all the bad things. This leads to microvascular damage, affects brain blood flow, cerebral blood flow, also triggers microglia, astrocytes, which triggers neuroinflammation. That leads to leaky blood-brain barrier. All of these is leaky blood-brain barrier. That, and also all this stress response triggers mast cell release. So mast cells release histamine, tryptase, serotonin, prostaglandins, basically inflammation. Interleukin 33, which is going to trigger, is like an epithelial inflammatory cascade. And that's all going to lead to more leaky blood-brain barrier. And that's going to lead to migraine, headache, pain, different changes in cerebral blood flow, brain fog, blood-brain barrier disruption, which can lead to autoimmunity, which can lead to, myriad of different problems, neuroinflammation, neurodegeneration, synaptic loss, Alzheimer's disease and dementia, which then further exacerbates chronic stress. So again, I'm not even scratching the surface on the contents of this paper, but I think that the pictures are worth 1,000 words. And I'm just seeing if there's anything else. But yeah, there's a lot of good stuff in this paper. But basically what it's saying is that stress needs to be modulated in a lifestyle way, of course, minimized, but also in a hormonal and a response way, which can be done through, various mechanisms of circadian rhythm support, adrenal support, adaptogenic herbs, vagus nerve stimulation, etc. And also that mast cells need to be supported as well. and possibly the neuroinflammation that is caused by this. So basically going back to this, there's a fire in the brain. We need to put the fire out. And then we need to look at, okay, what set this off? Was it this hand grenade? Okay, then we need to get rid of the hand grenades, meaning we need to stabilize the mast cells. Maybe not get rid of them, but stabilize the mast cells. And then we need to look at what triggered those things in the first place, and we need to address diet, lifestyle, stress, toxins, things like that, to kind of reverse engineer this problem of stress-mediated neuroinflammation that can lead to neurodegeneration. Whoa, there's a mouthful in that paper, but really, really good stuff that is applicable.